Hi, today what we're going to be looking at are some properties of exponents. What happens when you have terms that have exponents and you need to combine them? Before we get started and I explain what the properties are, I want you to think about some examples here. So let's say we have 7 times 7 times 7 times 7. What's another way we could write that? We could say that was 7 to the 4th power, right? It's 7 multiplied by itself 4 times. What's another way we could write that with exponents? We could say that there are 3 7s and a 1 7. Or we could say there are 2 7s and 2 7s. I want you to look at the relationship between the exponents in all three cases. What do you do in these two cases to get that case? What do you do to those exponents? We add them, right? So anytime you have exponents and you're multiplying, you're going to add the exponents. Let's break that down. So if you have the same base and you have powers that have the same base and you're multiplying them, you're going to add your exponents. So for example, we have 3 to the 5th power and we have 3 to the 8th power. They have the same base. They are both base 3, and we are multiplying them. So what that really means is we've got 5 3s over here. 3, 4, 5. And then we have 8 more over here. 1, 2, 3, 4, 5, 6, 7, 8. So altogether we have 13 3s. So algebraically the same way. Anytime you have the same base, you're going to take the exponents and add them up. So let's try that. We're going to multiply and we're going to write the products as 1 power. So if we have 3 to the 5th times 3 squared, what would that be? The same base, so we're going to add the exponents. We can simplify that as 3 to the 7th. Let's try 8 to the 10th times 8 to the 10th. We're just going to add those powers because our bases are the same. So it would be a to the 20th. What about 16 times 16 to the 7th? Remember, if there is no exponent, we assume that it is an exponent of 1. Fix that. So we're going to do our 1 plus our 7, so this would be 16 to the 8th. How about 6 to the 4th times 4 to the 4th? Okay, be careful on that one. Remember, they have to have the same base. Are 6 and 4 the same number? No, they are not. So we cannot combine those. It is already written as small of expression as it can be written. All right, so if we're dividing powers with the same base, I want you to think about that for a second before I tell you the rule. If we multiply and they have the same base, we add the powers. If we're dividing powers with the same base, what do you think we're going to do? Hopefully you got deep up on that one. If we add when we're multiplying, then we're going to subtract when we divide. So let's say we have 5 to the 5th divided by 5 cubed. We've got our 5 times 5 times 5 times 5 times 5 on top, and our 5 times 5 times 5 on bottom. Now, if this were a fraction, we could just simply reduce, right? This 5 cancels that one, this one cancels that one, and this one cancels that one, ending up with 5 squared. So all we really did is we took our 5 here, and we subtracted our 3 from the bottom, giving us 5 squared. So in the case of multiplying, we're going to add the exponents. In the case of dividing with the same base, that's important. Both of these have a base of 6. So we can do 9 minus 4 to give us 6 to the 5th power. All right, we're going to divide and we're going to write the quotient as 1 power, just like we did with the multiplying, only now we're dividing. So if we have 100 to the 9th divided by 100 to the 3rd, it's going to be 100 to the 9 minus 3. So it would be 100 to the 6th power. Now, every once in a while, we will get a 0 power. Well, what does it mean to have a 0 power? We know having a 1 power means that it is the single constant. So what is it when it's to the 0 power? You should know that any base, whether it be a 1 or a 100 or a million or cajillion, any number raised to the power of 0 is equal to 1. This is the reason why. So let's say we were taking this 1 and we wanted to turn it into a fraction. Well, any number divided by itself is equal to 1. So we could say 4 squared divided by 4 squared is equal to 1. Well, when we do that and we take our 2 minus our 2 right here, we would get 4 to the 0, which also has to still be equal to 1. So any number raised to the 0 power is equal to 1. As long as your a is not equal to 0 in algebra, so 0 to the 0 power, that's not an actual thing. You can't actually have that. So as long as your base is not 0, you're good to go. No matter what number is in there except for 0, it's going to be equal to 1.